Hi everybody. So I decided to break this screencast up into two screencasts because it seemed like it was getting too long. So in the first part of this series, we talked about the max and the mins, and we identified the intervals over which a function was increasing, decreasing, or constant. But in this screencast, we're going to focus on piecewise functions. So what I want you to see first is I want you to see what a piecewise function looks like. So a piecewise function is defined this way. So it's called piecewise because it's defined in pieces. So this function g of x is defined as 1/3 x plus 3 if the x values are less than 3, and negative x when the x values are greater than 3. So it's telling you which piece to use and when. So using that definition, I'd like you to try to find these four function values. So find g of -3, then 0, then 3, then 5. Pause the screencast, see if you get it right. So for g of -3 is less than 3. So we're going to plug it into the first piece. And we get the value of 2. And when we plug in g of 0, or 0 into g, 0 is also less than 3. So we're going to plug that into the same piece. So we get 3 as that answer. Now when I go to find g of 3, 3 belongs in this second piece because 3 is greater than or equal to 3. It's the equal to part. So that means it's going to be defined as -3. And 5 is clearly greater than 3. So it also is going into the second piece. So it's equal to -5. Did you get those same answers? All right, so now what we're going to do is talk about graphing this function. Okay, so my advice to my students, anytime they have to graph a piecewise function, this seems to be probably the one type of problem that causes the most difficulty in Chapter 2 for students. So graphing this piecewise function, the key here is that you need to know what is happening at 3. See, 3 is the endpoint of both of these intervals. I like to talk about it as a critical value. So it's a critical piece of information, and we need to know what's happening in each of these pieces of our function. So what we're going to do is we're going to plug 3 into the first piece, even though it's not defined there. I'm going to show you later how we show that it's undefined there. But we have to plug 3 into that first piece. And we're plugging 3 in because of this endpoint. If I was to plug 3 in here, this would end up being 1, and 1 plus 3 is 4. Okay, now for the sake of graphing this piece, I need one more point. So to graph a line, you need 2 points to connect them. So this tells me x has to be less than 3. So you can pick any number you want, but it has to be less than 3. I chose to plug in 0 because I felt that was easier. If I plug in 0, I get 3. Okay, I got to do the same thing with the second piece. Now, I have to plug in 3 because remember, I have to know what's happening at 3. So I'll plug 3 in, and then I picked an arbitrary number that was bigger than 3. I picked 5. You could pick whatever number you want as long as it's bigger than 3. So if I plug in 3, I get -3. If I plug in 5, I get -5. All right, then you graph those two pieces. Now here's the key. Remember I said 3 doesn't belong in this function. If I asked you for g of 3 like I did on a previous screen, you plug it in this side. So when I plug 3 into this function and I get 4, that actually is not defined. The graph is not defined there. So, or the function is not defined. So the way I indicate that is I draw an open dot. So if this is a less than symbol, you should see, or a greater than, and no line underneath it, you should see an open dot at then that endpoint. Compare that to this endpoint. For the second piece, we have a line underneath it. So that's why that piece has a closed dot. So look, when x was equal to 3, y would be equal to 4 here, but it's not included, open dot. When x is 0, y is 3, and you connect those points, put a little arrow on the end of that. Only going to the left because it's to the left of 3. And then for the second piece, we have an greater than or equal to symbol. So I start with a closed dot, and that's at 3, -3. And the next point is 5, -5, and I connect those points. Does that kind of make sense? All right, let's do another one together. So my last example here, here's a piecewise function that is defined in 3 pieces. So I'm going to make a table of ordered pairs for each of these pieces for when y is equal to 4, y is equal to x plus 1, and y is equal to -x. Those points that you plug in, some of them you can pick your own, but some of them are set in stone that you have to use because you've got to know what's happening on the graph at those specific points. And those points you have to plug in are these endpoints. So I've plugged them in the next screen. I have to plug -2 into the first piece. I have to plug -2 and 3 into the second piece. And I have to plug 3 into the third piece. So when I plug in -2, I get 4. When I plug in -3, I get 4. Why did I use -3? Because it's less than -2. For the second piece of the function, the y equals x plus 1 part, I have to plug in -2, which is -1, and 3, which gives me 4. And then in the last piece, I have to plug in 3, which gives me -3, and then a number bigger than 3, like 4. And if I plug in 4, I get -4. And then you simply have to graph those 3 pieces, remembering your endpoints: closed dot, open dot, open dot, closed dot. So look at the graph on the next screen. So we have a closed dot, and it's a constant function that's going to the left. Open dot, this is graph of y equals x plus 1, but it's only from when x is -2 until x is 3. Open dots on the endpoints, and then closed dot at 3 until we go to infinity, and this is the graph of y equals -x. All right, I know that's a lot to take in. If you need to, look over this video again, or you can, mute me talking to you and just go through the slides. I wish you a lot of luck, and email me with any questions that you might have. All right, see you next time.